Assalamu alaikum dear students, I am Miss Sada Bahar, a physics teacher, in Pakistan International School Doha, Qatar. Well dear students, I hope you all are fine. Today we will do revision of Unit 5 Gravitation. First of all, learning objectives of this lesson. Learning objectives. At the end of the lesson, students should be able to define gravitational force, state and explain Newton's law of gravitation, find the mass of Earth with the help of the law, explain variation of g with altitude, describe the motion of artificial satellite, differentiate between capital G and small g, and many more small topics, questions, with answers. Dear students, about the Newton's theory of gravity, the legend is that Newton discovered gravity when he saw a falling apple while thinking about the forces of nature. Whatever really happened, Newton realized that some force must be acting on falling objects like apples because otherwise they would not start moving from rest. That some force he called the gravitational force. Gravitational force. Every object in our universe attracts the other object with certain force towards its center. This force of attraction is known as gravitational force, and the phenomenon is called gravitation. This is gravitational force which is responsible for the uniformity or regularity in our daily astronomical life. The whole system of the universe is in order only due to this force. Due to gravitation, the system of our universe is working uniformly and smoothly. The planets around the Earth or around the Sun moves in an orderly motion due to gravitation. Dear students, I will explain Newton's law of universal gravitation. Statement. This law states that every object in the universe attract every other object with a force, which is directly proportional to the product of their masses, and inversely proportional to the square of the distance between their centers. Explanation. Consider two bodies of masses m1 and m2, separated at distance d from their centers respectively. According to the law of gravitation, the gravitational force of attraction F between them is F is proportional to m1 m2, and F is proportional to 1 divided by d square. By combining equations 1 and 2, we get F is proportional to m1 m2 divided by d square, or F is equal to g m1 m2 divided by d square. Here g is the constant of proportionality, called the universal gravitational constant. Value of g. If m1 equals m2 equals 1 kg and d equals 1 meter, then F equals g. Thus g is a force which 1 kg object exerts on another 1 kg object placed 1 meter away from it. In SI units, the value of g is g equals 6.67 by 10 power minus 11 Newton meter square per kilogram square. Question: why we do not observe force of attraction between any two bodies around us? Answer: since the gravitational field between different bodies around us is very small, as the value of g is very small, so we do not feel it. However, if the mass of one object or both the objects is very large, then we can observe the effect of gravitational force easily. Dear students, now I will tell you the difference between capital G and small g. Number 1, capital G is the universal gravitational constant, whereas small g is the acceleration due to gravity. Number 2, in SI units the value of capital G is 6.67 into 10 power minus 11 Newton meter square per kilogram square, whereas the value of small g is approximately 9.8 meter per second square on Earth's surface. The value of small g varies from one place to another on Earth. Number 3, capital G is constant throughout the universe, whereas the value of small g changes every place on planet. For example, on Moon's surface the value of small g is 1/6 of that on the Earth's surface. Dear students, Newton's law of gravitation help us in calculating the mass of Earth. Now, going to find the mass of Earth with the help of the law. Mass of Earth. Consider a body of mass m placed on the surface of the Earth. Let the mass of the Earth is m and radius of Earth is r. Gravitational force of attraction between Earth and body is F equals gmm, divided by r, square. We know that the force of attraction of the Earth on a body is equal to weight of the body, that is, F equals W, therefore, W equals gmm, divided by r, square, but W equals mg, so, mg equals gmm, divided by r, square, or, g equals gm, divided by r, square, or, equals gr, square divided by g, as, g equals 9.8 meter per second square, r, equals 6.4 by 10 power 6 meters, g equals 6.67 by 10 power minus 11 Newton meter square, per kilogram square, putting in equation 1, equals 9.8 into 6.4 by 10 power 6 whole square, divided by 6.67 by 10 power minus 11, or 5.98 into 10 power 24 kilograms, or 6 into 10 power 24 kilograms. Dear students, according to Newton's, the weight of a body is due to gravitational force with which Earth attract a body. The gravitational force is a non-contact force or gravitational field force. Now first, I will tell you what are contact forces and what are non-contact forces. Contact forces. Contact forces are forces that act between two objects that are physically touching each other. Examples of contact forces include reaction force, tension, friction. Non-contact forces. Non-contact forces are forces that act between two objects that are not physically touching each other. Examples of non-contact forces include magnetic force, electrostatic force, gravitational force. 1. Show that gravitational field force is a non-contact force. Answer: as the velocity of a body, thrown up, goes on decreasing while on returns its velocity goes on decreasing, it is due to the gravitational pull of the Earth, acting on the body whether the body is in contact with the Earth or not. Such a force is called the field force or non-contact force. 2. How you can say that gravitational field exists all around the Earth. Answer: it is assumed that a gravitational field exists all around the Earth. This field is directed towards the center of mass of the Earth. The gravitational field becomes weaker and weaker as we go farther and farther away from the Earth. 3. Define gravitational field strength. Answer: GFS in the gravitational field of the Earth. The gravitational force per unit mass is called GFS of the Earth. At any place its value is equal to the value of G at that point. Near the surface of the Earth, the GFS is 10 N per kilogram. Its SI unit is N per kilogram. Our next topic is variation of G with altitude. As we know that on Earth's surface, G equals gm, divided by r square, here G and m, is constant. Therefore, equation 1 becomes, G is proportional to 1 divided by r square. The above equation, 2, shows that the value of G depends on the radius of Earth. The value of G is inversely proportional to the square of the radius of Earth. The value of G varies as the distance from the surface of the Earth varies. Formula of G at altitude, h from the Earth's surface. Suppose a body of mass m at an altitude h. The distance of the body from the center of Earth is r plus h. By using an equation 1, we have gh equals gm, divided by r plus h, whole square. According to the above equation 3, we come to know that, at a height equal to 1 Earth radius from the surface of Earth, G becomes 1/4 of its value on the Earth. At a height equal to 2 Earth radius from the surface of Earth, G becomes 1/9 of its value on the Earth. What is satellite, artificial satellites, and what do you know about communications satellites? Answer: satellite, an object that revolve around a planet, is called satellite. Artificial satellites. Scientists have sent many objects into the space. Some of these revolve around the Earth. These are called artificial satellites. Most of the artificial satellites orbiting around the Earth are used for communication purposes. Artificial satellite carry instrument or passengers to perform experiments in the space. Communication satellites. Communication satellites take 24 hours to complete their one revolution around the Earth. As Earth also complete one rotation about its axis in 24 hours, hence, these communication satellites appear to be stationary with respect to the Earth. It is due to this reason that the orbit of such satellites is called geostationary orbit. Dish antennas sending and receiving the signals from them have fixed direction depending upon their location on Earth. Dear students, now we will learn about motion of artificial satellite. A satellite requires centripetal force that keeps it to move around the Earth. The gravitational force of attraction between the Earth and satellite provide this necessary centripetal force. Mathematical derivation. Orbital velocity. It is the velocity of the satellite which moves around the Earth at specific height. Suppose a satellite of mass m revolve around the Earth at a height h in an orbit of radius r, o with orbital velocity v, o. The centripetal force, Fc, is given by Fc equals m v o square divided by r o. This force is provided to the satellite by the gravitational force of attraction between the Earth and the satellite, which is equal to the weight of the satellite, that is, Fc equals W equals m, gh. By comparing equation 1 and 2, we get m gh equals mv o square divided by r o, or v o square is equal to gh r o, or v o is equal to square root of gh r o. Here, r o is equal to r plus h, v o is equal to square root of gh into r plus h. This equation represents the orbital velocity. An approximation can be made for the satellite revolving very close to the Earth, such that r is greater than h, therefore, r plus h is nearly equals to r, and gh is nearly equals to g. v o is equals to square root of gh into r, as g is equal to 9.8 meter per second square, and r is equals to 6.4 into 10 power 6 meters. By putting the values in the above equation, we get v o is equals to square root of 9.8 meter per second square into 6.4 into 10 power 6 meters, or v o is equals to 8 kilometers per hour. A satellite revolving around very close to the Earth has speed nearly equals to 8 kilometers per hour. Dear students, I hope you have learnt the Unit 5. Now for practice, attempt all the exercise questions, past papers questions, and question in the posted worksheets. At the end I would say, take care, thanks.